Today we're going to talk about how to write equations of lines, and I want to give you a variety of methods for how you can do that. And so by the end you should be able to choose the method that suits you best for writing the equation of a line. In order to write the equation of a line, you need to have two things. You need to know the slope, which is our m variable, and you need to know a point on the line. The point on the line can be either an xy point or it could be the y-intercept b. Okay, there are three forms of the equation of a line. You have your slope-intercept form, which is y equals mx plus b, which is you'd be looking for your slope and your y-intercept to substitute in. You have point-slope form, which is y minus y1 is equal to m times x minus x1, and what you're going to be substituting in and looking for is your xy point and your slope. And then we have standard form. Standard form is not quite as easy to use, and so I want you to know that it exists, and sometimes we'll take these, and we did this the other day, we converted it into y equals mx plus b so that we could graph it. It is useful, and but we won't be having you write equations in standard form today. Okay, so we can, we know how to start with y equals mx plus b and get a graph from that. And so I want to go back to what you already know and take the reverse. So if you have a graph, we should be able to write the equation of this graph by using what we used originally when we learned how to graph it. When you learned how to graph an equation, you would start at the y-intercept, and then you would do the rise over run of the slope, and then you would connect 2 points because it takes 2 points to make a line, and you would find that, you would connect those 2 points, and you would draw in your line. So if we want to find out what the equation was that created this, we'd do the same thing. Start by finding your y-intercept. So there is your y-intercept, that's your b, and then we need our slope. So what you want to look for with your slope is look for places where the line crosses the grids in nice, pretty places. And then you want to pick a stair step, right? You want to look for those stair steps. And so this one goes down 1, so it's a -1, and to the right 4. Remember, down and to the left are our negative directions, and up and to the right are our positive directions. Don't forget that. And so the slope of this line is -1/4, and the y-intercept, which is a point on the line, is at +2. So we need the slope and a point to be able to write the equation of a line, and we have those two things, so we can write it. Y equals, and I wanted slope-intercept, so I'm going to go with this form right here. Y equals m x and then plus b, which was 2. And that is the equation of that line. So if I had started with the equation, I would have gotten that graph in the end. Okay? You can also, as an option, if you are looking at a problem where I ask you to write the equation of a line, one of your options if you get stuck is to go back to what you know. You know how to take the equation off of a graph, so if you ever get stuck, put it on a graph and see if you can get the equation that way. So we have a slope of 3 and we have a point of this x and y. Okay, so if I want to use the graph, remember we did this the other day, we graph the point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and you would put that point on there. That's our point, and we have a slope of 3. Well, I can go up 3 over 1, but what I really want to know, and I could connect those, but I'm relying on my pencil width being right, my dots, and all of that stuff. So the easiest thing to do is to count your slope in reverse, right? Down 3 and to the left 1, which is 2 negative directions. So it makes it positive 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And that point right there is at -8. And so if I were to connect those dots, right, all the way down, this is what it would look like, although we don't really need to know what it looks like because our goal was to write the equation of the line. The equation of the line now then is y equals, we have our m, 3x, and then plus b, and our b was a -8, so it will be minus 8. That negative and the subtraction are interchangeable depending on how they're used. So we get that equation is y equals 3x minus 8. Now, I also want to show you how to do the same thing, same problem, but I'm going to do it 2 different ways with an equation. So then that way you can see it works with the graph, and then it works by using the slope-intercept form, and it works by using point-slope form. Now, my preference is point-slope form. I like it because it cleans up very nicely and it does everything. It takes care of all of it all in one step. I'll show you the difference. So we're going to work this 2 different ways. One, we're going to work it with point slope form because I need a point and a slope to write the equation of a line. That's what I have. There's my m, there's my x and my y, my x1, y1. That's the point in question. And then I'm going to also show you how to do it with y equals mx plus b using points or using your slope intercept. So what I like to do is go back and write the equation with the blanks. What we're trying to find or what we need to replace with numbers is y1, m, and x1. And so if we go in and rewrite it, I like to write everything just like it is, what I call the skeleton of the problem. So I'm rewriting everything except for the y1, the m, and the x1. And the reason I want to do that is because then when I go back in and substitute in my numbers, I won't make mistakes with my signs. You'll see that in the next example. So my y1, my y value was 7, my m value was 3, and my x value was 5. So that made it easy. I didn't make any mistakes with my signs. Now, in order to get it into slope-intercept form, I started with point slope, but I want to end in slope-intercept. What we need to do is clean this right side up. So we get y minus 7 equals 3 times x is 3x, and 3 times negative 5 is negative 15. We need it to be y equals, because we need y equals mx plus b in the end. Then we're going to add 7 to both sides, and we get y equals 3x minus 8. Notice that that is exactly the same equation that we got when we did it on the graph. And we should have. It had the same slope, same point. So the equation of the line should be the same. So that's what I want you to see is you have a variety of methods in how to do this. Okay, now some of you know how to do this with slope-intercept. So this is how you do this. We need our intercept. We have an x, we have a y, and we have an m. So I have a y, I have an m, I have an x. I need the b. So here's what you do. You substitute those numbers in. So y is 7 equals m is 3, x was 5, and then plus b, which is what we're looking for. So I get 7 is equal to 15 plus b. I need to solve for b. That was the one thing I was missing because in every equation, like I said, when you write the equation in slope-intercept form, you're going to have a number where the m is and you're going to have a number where the b is. So we need that b. So I subtract 15 from both sides and I get negative 8 is equal to b. So now we have our slope, or we have our y-intercept. I need to go back and I need to rewrite the equation now with the slope and the y-intercept. Y equals 3x minus 8. Now, this is why, notice, they're all the same answer, right? If I used graphing, I got the same answer. If I used point slope, I got the answer. And if I used slope-intercept, I got the same answer. All of them are the same. I prefer this method right here because this one's just a little more hard logically to think, oh, I need b, I got to find b, and then I have to go plug it back into the equation. But if this is what you're familiar with, then this is the one that you should use. You have options. You get to pick which one you're most comfortable with. I'm going to continue with point slope so that you can see it, but feel free to use slope intercept if you choose, or always go back to graphing. Okay, so let's look at this one. Write an equation in slope-intercept form. That means we're going to end in y equals mx plus b. It doesn't mean we have to start that way. It just means we have to end that way. With a slope of 1/2 containing the point negative 8, 5. So there's my x1 and my y1, or my x and y. I want to use point slope, y minus y1 is equal to m times x minus x1. Remember, we're going to replace the y1, the m, and the x1. We're going to replace those with the numbers that we were given. Now, again, here's what I like to do. Y minus, leave a blank. and then I'm leaving a spot for m, and then x minus. And I do that because of those minus signs. Those minus signs make things complicated, and people think that because this one's negative, that counts for that minus. That's different. You cannot, they're not the same because the minus comes standard with the problem. So you have to keep that x minus. And so that's why I like to go ahead and write this out and then substitute in my numbers. So I need y1, so I go over here and I get it. It's a 5. I'm just going to write in a 5. And then m is negative 1/2. And then x minus, I need x1, it's negative 8, and so I plug in a negative 8. Then I deal with the signs. There's this double sign right here. We don't like double signs, so I'm going to make that minus a negative into plus a positive. From here, we want it in slope-intercept form, so even though we didn't start in slope-intercept, now we need to finish it out by distributing this negative 1/2. So we have y minus 5 on the left equals negative 1/2 times x is negative 1/2 x, and negative 1/2 times 8. If you're not comfortable with multiplying by fractions, it's negative 1 over 2 times 8. Technically, that's over 1. So you would multiply the numerators. Negative 1 times 8 is negative 8 over 2 times 1, which is 2, and that simplifies to negative 4. Or half of 8. Right? You can also think of it like that. Half of 8 is 4, and it's negative times a positive, so it'd be minus 4. And if all else fails and you're not comfortable with it, type in your calculator negative 1 divided by 2 times 8, and you'll get negative 4. We need to clean it up so we can finish it out and make it look the right way. So we'd add 5 to both sides, and you get y equals negative 1/2 x plus 1. And I could always put that on your you could put that on a grid, and you could get the exact same thing. The only time the grid doesn't work is when your y-intercept is either not on the grid or it's a fraction. In that case, using the graph is not very helpful, but it works when the numbers come out nice and pretty. Okay? Now, what if I don't give you the slope? Well, remember that we know how to find the slope. Remember, it takes a point, and it takes a slope. So we need a slope, and then we need a point. I have 2 points. Well, if I have 2 points, I know how to calculate the slope, right? y2 minus y1 over x2 minus x1. We've been doing that for a long time now. So pick your order. It doesn't matter which one comes first. I'm going to start with 14 because it's biggest. So 14 minus 6 over 2 minus 4. Remember, pick a direction and keep going that way. If I started with 14, I have to start with 2. So 14 minus 6 is 8. 2 minus 4 is negative 2. And simplify. 8 divided by negative 2 is negative 4. So my slope is negative 4. Now, in order to write the equation of a line, we need a point and a slope. Notice I have a slope and I have 2 points. That means you have choices. So here's what I would do. I have choices between which points I want to use. So I'm going to choose this one. Now, it doesn't matter which one you pick. We'll all get the same answer. If you don't believe me, try it. You'll see. But I picked that 4 and 6 because they're smaller. That's the only reason. 4 and 6 are smaller than 14. And so that is the reason I am going to choose 4 and 6. There's nothing magical about that. I'm just trying to make it easy. Now we have the slope and we have the point just like we did up here. So now you go through the same steps. Y minus, we want our y1 equals m times x minus, and then we're going to plug in those numbers. Remember, we're going to substitute for y1, for m, and for x1. And we got those pieces earlier. So we have y minus y1. There's my y. It's 6. And then slope is negative 4. And then x minus, there's my x, 4. And plug it in. Simplify this. I want it in slope-intercept form. So I didn't start in slope-intercept form, but I'm going to end in slope-intercept form. I need to distribute that negative 4. So I get y minus 6 is equal to negative 4 times x, and negative 4 times negative 4, that's positive 16. Add 6 to both sides, and you get y is equal to negative 4x plus 22. So that would have been nice and pretty to graph, except you might not have had a grid that had 22 squares on it. And so that one might have been a little more difficult to graph. But you can still do it on a grid. It would just have to be a big grid. Okay, and you could still use y equals mx plus b. If you want to start and finish that way, you can do that too. You just have to remember, find the y-intercept and then plug it back into the equation. So we're going to do the same thing here. Notice, write the equation of a line in slope-intercept form that passes through those 2 points. Okay, so I want to write the equation of a line in slope-intercept form, and it's going to pass through -4, -2, and -2, 1. In order to write the equation of a line, remember, it takes 2 things. I need a point, and I need a slope. I don't have either, but I have 2 points, which means I can calculate the slope. So slope is y2 minus y1 over x2 minus x1. Simplify all of this. So 1 plus 2 is 3. And 2 minus the -4, or 2 plus 4, -2 plus 4 is +2. So my slope is 3 over 2. Now, it doesn't matter. Again, I have 2 points. I only need 1. I will pick this -2, 1 simply because it only has 1 negative. Now, you might want to pick the -4 or -2 because they both have negatives and they're both going to behave the same way. We go back and we always start in our point slope. I choose to start in my point slope form. You can choose a graph or you can choose slope intercept. It doesn't matter. So y minus, we're going to fill in that blank, m, and then x minus. Those are all the standard pieces of the equation. And then we're going to substitute in our numbers. So y minus, I'm using this point. You can use whichever one you want. So y minus y, which was 1. Slope was 3 over 2. And then x minus -2. Okay? I'd like to write that skeleton so that I don't make mistakes right here. You have to be very careful. Don't make mistakes. X minus, and then go get the number. Well, we're going to clean that up and make it positive. Now, in order to finish in slope-intercept form, you have to distribute that 3 over 2. So I have y minus 1 equals 3 over 2 times x is 3 over 2x. And then 3 over 2 times 2. If you're not comfortable with it, type it in on your calculator. 3 divided by 2 times 2. Or you can do 3 times 2, which is 6, divided by 2, which is 3. Or if you notice it, that 2 here in the denominator cancels that 2 that's in the numerator. Okay, we need to finish this out. Add 1 to both sides. And we get y is equal to 3/2 x plus 4. Again, this would have been a nice pretty problem on the graph. So you always have options. You have at least 3 options. You can put your slope and your point on the graph. You could have put those points on a graph and then counted the slope and then found the y-intercept and then written the equation in slope-intercept form. You can start with point slope and end in slope-intercept. Or you can start with slope-intercept and end with slope-intercept. All of them work to get the same equation of the line.